If you take advanced chemistry someday, we have study sessions before every test, but it's outside of school time. You can come here at 7 o'clock at night, study for 3 hours together. Good. School's gonna get harder. But thankfully, you guys, as you get older, gain knowledge and you progress in your maturity, and you'll be able to do bigger and better things. Physical science, not super thrilling. Higher level stuff, pretty sweet. Okay. That's why a lot of times I end up talking about things from other like later classes, because it's like the cool stuff, even though you don't really know what I'm talking about at this point yet. So, yeah. All right, so we're 2C. So still chapter 2, section C. We're talking about matter, being able to classify matter, talked about the theories of matter. Now we're going to talk about some changes of matter. Not taking notes today, Moira? If I have to. All right. Physical properties. I don't think today's notes will be as long. I'm almost positive you'll probably have a question on your standardized tests that you take this year. Did you guys do that in middle school? Did you guys take those standard tests?
Yeah.
I'm pretty sure you'll have a question on your test that'll be over this topic right here. Today's lesson. So we'll see if you guys remember it, you know, what, 5 months from now. Hopefully. Physical properties. All right, if we look at the definition of a physical property up here, it says, can be observed or measured without changing the kind of matter being observed. What is the big key words up there in that definition? No? What would really be the way to identify this between maybe some other type of definition? Because we're going to talk about a chemical property as we progress. Yes. Without changing the kind of matter. That's probably, that whole phrase there is the big important phrase. Because when we talk about a chemical property, that is a property that does change the kind of matter you have. Because it's chemical. Remember when we talked about a mixture versus a pure substance, and how a mixture you could change physically? And a compound or whatever, a pure substance, could only change chemically? Right? Kind of like that kind of idea. Okay, so any ideas, a physical property that you can observe, you can measure without changing the identity of the thing you're looking at. May not be super easy to come up with some until we talk about it a little bit more, but any ideas? Okay, what about that stool that you're looking at would be a property of that stool? You could change that it's a solid if you heated it up. Now, that's probably not the best example, but like for example, if you had water, could you change the phase of the water? Actually, that would be a physical property. You are right. Because is it still water? So when you boil water, is it still water? When you freeze water, is it still water? It's not water, bros? Well, it's just frozen water. We give it a different name, we call it ice, but it's still frozen water. Okay, so yeah, that would be a physical property. So melting something, freezing something, boiling something, and condensing something are all physical properties of a specific object. Here's some other ones. Color. Could you observe a color without changing the fact that it is what it is? Your hair is brown. I can cut your hair. Is your hair still brown? Now, dyeing your hair would be a chemical change, right? Or at least a temporary one. Okay? Other things that you could have for a physical property. There's a few others. Those aren't the only ones, but those are a few others. Does anybody know what malleable means, or malleability? You'll learn about it later, but I don't know if you know it now. It's like the chemistry term for pliable. Metals are typically very malleable, and so you can bend them. Believe it or not, yeah, metals, they're bendable. Ever seen a paperclip? Can you bend a paperclip pretty easily? Okay, that's a property of a metal. Doesn't change the fact that it's a certain kind of metal. I don't know what paperclip the metal is that makes a paperclip. I really don't. Okay, magnetic would be another physical property. Okay, observing that something has a magnetic field to it does not change whatever the substance is. Okay? So here's the big key. The big key for physical. Without what? Changing what it is. Okay? If this property changed what it was, we would call it a chemical property, and we're going to define that in a little bit. Okay? Big thing. You should highlight, underline, put a star. That is the way to identify it. So if we go back to this, conductivity. You guys probably don't know what that is. You guys know what that is? Its ability to conduct heat or electricity. It's an ability it has that doesn't define what it is. Metals conduct heat and electricity very well. Does that change the fact that it's a metal? No. Okay? Physical change. It's a change in the physical property. Sorry. our life. All right, you're still seeing a theme here. So a physical property is something that we can define it physically without changing its identity. And if we do a physical change, it's just a change in the physical property, but you still have the same stuff. Your hair is black. I can cut your hair. Still black, still hair? Physical change. Here's some other physical changes. Dissolving. Any of the phase changes like melting, boiling, you can go cutting. What other things that I can think of off the top of my head? It's probably enough, at least a start on this. We'll go through some more examples when we get to both of them. But all right, so dissolving. So if I took salt and dissolved it in water, why is that a physical change and not a chemical one? Any ideas? So you're saying when I dissolve salt in water, I still have water and salt. They're not chemically combined. Okay, and how do I know? Remember when we talked about a mixture? We talked about mixtures can be physically separated, and wasn't salt water one of those mixtures? So anything that's a mixture, okay, can be physically separated. It can be physically separated by a physical change. So what is the physical change that you would have to do to separate salt water and to get salt out of the water? You'd have to boil off the water, and you'd have the salt left over. Okay? Did I need to do anything chemically to that? Do I still have the same things before and after? Okay? We talked about all the phase changes. When I take ice or solid water and I melt it, it did its identity change. For some reason, this actually gets a lot of kids. They think that it's something different. Like if you boil water, just because you can't see it, doesn't mean that it's not water. And would this be the case for anything that you boil? Like you could boil alcohol, it's still alcohol. You could boil sugar, that'd be hard to do, but you could do it. Yeah, it'd probably burn before it would change phase very well, because it's not super stable in the gaseous form. But, okay, so the big thing here, after the change, do you have the same thing? That's what you should ask yourself when you come across these types of changes. After the change, is it still the same? When I dissolve salt in water, is it still salt in water, or is it something chemically combined like some new compound? After the change, is it the same, or after the change, is it different? And once I give you chemical change as well, I think you'll be able to distinctively tell the difference. All right, there's just some examples. I didn't know I had examples for you. Cutting a piece of paper. Still paper. Change the shape of the paper, maybe the size of the paper, but still paper. We talked about freezing water, we talked about evaporating alcohol, compressing a gas. Is it still the same gas, or is it a different kind of gas when you compress it? It's what? Same kind of gas, I just remove the space in between them, essentially, right? You could add dissolving water, you could add quite a few things. How about breaking glass? Physical or chemical? Physical. So the glass is still glass, it's just in small pieces. Right? What else? Mowing the lawn. Still physical. Still grass. Mowing a hamster. Sorry, that's probably a little morbid there. I don't know the answer to that one. Probably some sort of chemical. I don't know. Probably physical. Just physical that resulted in death. Yeah. I've ran over. I've accidentally I've accidentally mowed over a rabbit before. A baby one though. He's like, shame on you.
It was even worse.
I didn't know it was in a little hole and it was hidden, and then they came out and just go. That bothers somebody.
I run over like first week.
All right. Wow. It's gonna help you with your extra credit. Do I not have chemical property on there?
No, you don't.
Oh, it's probably. Are they the same definitions?
No, they're different. Yeah, this is.
Yeah, change that to chemical on your note, on your vocab sheet. I guess I didn't change the vocab sheet. Well, I just copied and pasted the name. The definition's different.
Yeah.
I just, oops.
Hold on with
Mari, I gave you a vocab sheet, right? All right. What's the phrase that's important here for chemical property? Substance changes to another substance. You have an identity change. We didn't have an identity change in a physical property. You wouldn't be able to know the property until you saw the change, essentially. Okay? I'm guessing there'll be a couple examples that will be up in your notes, so I'm not going to write them on the board right now. Okay, the big thing here is it has to result in a change in what it is. If it doesn't, it'll be physical. Do you see how they're only separated by one, no identity change, other, result in an identity change? Really, that's the only difference. Okay? So this isn't as complicated as it maybe seems. There we go. Do I not have any examples? Oh, yeah, there is. So this first bullet is just showing you that the chemical change can only occur if you've got old bonds breaking, new bonds forming to form some new substance, new identity. We'll talk more about bonds forming and bonds breaking when we get into doing chemical stuff. already talked about this, I don't need to spend any more time talking about this slide. If you notice, it says alters the identity. Does it change identity or does it stay the same? That's a question that you can use to distinguish between a chemical and a physical property and or change. I don't want to switch the slide until you guys are done with it, but I don't want to linger on this since I've already spent time talking about it. This one's some pen's moving, so I'll wait. Got some examples on the next slide. Done, Everett? Don't put in D. I'm not going to talk about it. Just put in C. Do not put in D. You can put in oxidizing, but you won't have any idea what that is. It is a very difficult thing to talk about without knowing some other information about it. But anytime you burn, no matter what it is, you burn it, chemical change, because there's a reaction going on between what it is you're burning and the oxygen in the air. Okay? It always results in a chemical change. So burning will always result in a chemical change. Now you may or may not have known this, but the process of rusting is a chemical one. It doesn't just like get this yellow stuff that just is on it for, it's not just the color. Okay, when you see a nail rust, what's happening is the oxygen in the air, and usually so it's gotten a little damp, that there is a chemical reaction between that, and it becomes a completely new identity, even though, you know, it only appears to change the color. Okay, so when a nail rusts, it's not just a copper nail or an iron nail or whatever it is anymore. It's a compound that now has been bonded with oxygen. Yes? Yes, corrosion would be a chemical change too. Usually they call the chemical property of burning flammable. So like flammability would be the chemical property, burning would be the change of it. That makes sense? Let's do some problems. See how we got this down. You don't have to write this in. Unless you want to, I guess, but nah, it'll take too much time. Okay, so I want you, maybe you just put in your notes like 1 through 8. What I want you to do is to try to determine if this is chemical or physical on your own, and then we'll come together as a group and we'll talk about them. Does that make sense? So maybe just do like 1 and then you can put P or C, or if you want to do physical or chemical, that's fine too. But I want you to at least try to do this on your own. What is the question you should ask yourself? Yeah, is it the same thing after the change, or is it something different? Now some of these might not be as obvious as others, and it's just through experience will we get to understand some of them. But there's usually a couple words that give it away. little buzzwords that are like, oh, that word has to result in a chemical change, or that word definitely tells me it's just physical. However, there is some words that can be both. Okay? Are we giving it a try? We still working or thinking about it? All right, someone raise your hand. What do they think this one is? Oh, everyone's confident. All right, Jared, what do you think? Yes. It is physical. Why? Yeah, when you boil the water off, you have the salt at the bottom. Okay, it's not chemically combined. Now this one you wouldn't know unless I told you, probably. Okay, all the water does is surround the salt. It doesn't bind or chemically bond to it. All right? This one you may have not have known unless I told you today, but we'll see. What do you guys think? Shane? Chemical. Okay, there's an actual chemical reaction that appears when you have a nail or some sort of metal rusting. Okay, this one shouldn't be too bad either. Anybody? Rose? Physical. Still glass. Just broken glass. Smaller pieces of glass, but still glass. Yeah. Break that window. Still glass. Okay. 4. Carly? Piece of paper burns. What's the big giveaway? Burns. So there's the buzzword to make it chemical. You could say this is the buzzword to make it physical. This is the buzzword that makes it chemical. You could even say this is always going to be a physical. If I break something, it should almost always be physical. I can't think of a situation where breaking it would cause a chemical change. At least not off the top of my head. Unless you like broke something that allowed two things to mix that chemically reacted. But yeah, like they might have those like those portable, like they use in the first aid kits, the portable like cold packs that you have like snap and then it gets like really cold. Well, like glow stick would be another example. That's a chemical reaction. But it's only the only reason there's any chemical reaction is because the breaking allows two things to mix. Does that make sense? Yeah. The breaking would be physical, and then the result of that led to a chemical change. So, yeah. All right. Number 5. Anybody? Shane? You didn't raise your hand. I'm looking at Steven. Steven, sorry.
Chemical.
Okay. What was the giveaway? Any idea? Okay. Heated can be both. There's a different word. Form. If you say you're forming something, usually that results in some chemical. And then you read the context. We started with iron and sulfur, and then it says we got a different substance, or we formed a new substance. Here's why heating isn't necessarily chemical or physical. What do we have to do to get something to boil? Heat it. But what kind of change is that? Physical. Do you see how it depends on the situation for heating? Does it depend for burning? No, burning's always what? Chemical. Oh, oops, why am I doing that? We got 5 done? 6. You might have had to experience this to know for sure, but chemical. Okay? But there is a buzzword that will help us with this. What is it?
Yeah.
Reacts. That's the buzzword. Anytime you see the word reacts, you're gonna have a new identity or a new substance every single time. You see how there's like a buzzword in every one of these? If you can identify the buzzword, you can identify what it is. Okay, next one. This one should be easy. But everybody, shout it out. Physical. It probably wasn't physical until we talked about identity, right? I get a lot of people that if they don't know the difference between chemical and physical, they would probably think it's a chemical change. And last one. Chemical. What's the giveaway? Produces. And it tells us I had zinc with hydrochloric acid, and it gave us, did we start off with hydrogen gas? No, it's a completely different identity. I do have one more slide I think to get in here. Okay? It's a nuclear change, I believe. But we won't like identify a nuclear change, we'll just define it. These changes require or result in a lot of energy. Is this real easy to do? The only way to do a nuclear change is to change the atom, what's in the atom's nucleus. Hence why we call it a nuclear change. Do you remember what I said determines the identity of an element or an atom? How many what it has? You might know? You may remember? Protons. Okay? The protons determine the identity of an element. If you change the number of protons, you have a what kind of change? Because you're changing the protons in the nucleus. Okay, this results in lots of energy, either required or given off, and is a big component of the atomic bomb. I think if you, once you get this in, you can just leave because this is pretty self-explanatory if you read it. Nuclear change is a change that occurs in the nucleus. When you get this in, you may leave.